All right. Now, section 8-9, we're going back to here. And it actually is kind of a nice review. It's been a little bit, we had this chapter in between on linear systems of equations. And the chapter before that, we were looking at linear equations in general, okay? And that was chapter 8. We're going back here to chapter 8 to look at something a little more closely, and that is proportionality or variation, okay? And this section here is all about direct variation or proportionality, okay? Now, this is a term you have probably heard before. You've probably heard someone say, this is directly proportional to this. Okay, and what does that mean? How many of you have heard someone say something like that? Okay. Any one of you has ever heard that statement before? Something is directly proportional to something else?
Sounds familiar. I don't think I've heard it. I don't
Okay.
know.
Well, what we're talking about when we're talking about something that's directly proportional, and this is as opposed to inversely proportional. Okay? Directly proportional means that we have two variables, okay? And as one changes, the other changes in the same way. Okay? According to a particular ratio. Alright? Or maybe instead of in the same way, we should say in the same direction. Okay? And it will change in that same direction according to a ratio or a constant of, we call it a constant of proportionality. Okay? So, we have these two variables. And let's say that I have a variable, I'll make a little table here to show us, okay? Let's say my two variables are hours worked, okay? Hours worked is one variable. And the other variable is how much pay I've earned. Okay? Now, what would you expect to happen? Let's start with a first example. Let's say I don't work at all. What should I expect? I should expect nothing. Alright? Unfortunately, not everyone in this country would agree with me. Alright? But if we don't work, we don't deserve anything. Let's say I work 1 hour and I make $12. then I work 2 hours. How much would I make? Okay, I'd make $24, right? And I could keep going. 3 hours, I would make $36. 4 hours, 48, and so on, okay? Now, you'll notice they're not changing the same amount, okay? It's not like every 1 hour my pay is going up 1. Right? That's not what we're talking about directly proportional. However, they're going up in the same proportion. All right? In other words, when this went up 1, this went up 12. And then when this one went up 1 more, this one went up 12 more. When this one went up 1 more, this one went up 12 more. And so forth, okay? It's going up in the same proportion. There's a constant proportion there. And notice both of them are increasing. Okay? Both of them are increasing. So this is increasing, my pay increases. Excuse me. This is what's called directly proportional. Now, can someone tell me what an equation for this would be? Let's say my hours worked is my X, my pay earned is the Y. Could someone help me write an equation to illustrate that? Anna Marie?
X equals 2y, and like 2x equals 2y something. Like, because you would do x times 1, like it would be 2, and then you already have your y equals 12, which you would have that x equals 24. That would be.
We need to figure out a way to use this number to get this number. That's what we're trying to do when we're writing the equation. Sam?
2, well, can you do like 2x? Oh wait, what are we trying to, like, sorry.
An equation that would illustrate this.
Okay, well, never mind.
Well, we pay attention rather than draw pictures. Try to figure it out. Madeline?
X plus 1 equals 5 plus 12.
No. You guys are actually thinking kind of recursively. Like, we're going to take this step and then do this and this step and do this and this step and do that. You're thinking too hard. Okay? Peter?
X equals 12y.
Wait.
5.
There we go. Y equals 12x. Alright? The amount you get paid equals 12 times however many hours you worked, right? Okay? Your pay equals $12 an hour. Okay? Right? Okay? You guys are thinking a little too hard on that one. Okay. So, as I look at these, I would say that y and x are directly proportional. They're directly proportional because as one is increasing, the other will increase at the same constant rate. Okay? Now, I mentioned this term constant of proportionality. Well, here's how all of these will work. All of these relationships of variables that are directly proportional can be written this way. Y equals kx. All right? And the constant of proportionality is that k. All right? Now, I want you to try to I want you to try to relate this to what we've learned before, okay? What does this look an awful lot like that we did before? Anna Marie?
It kind of looks like substitution because you plug that into your problem, like y equals 2x and 12x.
Okay. It kind of looks like when we were doing substitution, we'd solve for y and plug it in, okay? What else does this look kind of like? Giovanna?
So the x and the y is like the x and the box that we did.
Okay, let's keep going with that idea. It kind of looks like the XY box that we did, and actually that is exactly what this is. Okay?
Y equals mx plus b.
Yeah, y equals mx plus b. It looks an awful lot like, what was that called? Slope-intercept form, okay? What's unique about this, though? What differentiates this from kind of just the standard slope-intercept form? What don't we have? Jacob? Well, we could graph it. We could graph it if we wanted to. Madeline? Yeah, we don't have a y-intercept. Or actually, I should say, our y-intercept equals 0. Okay? Basically, when we're talking about something being directly proportional, we're talking about something that has a linear relationship with a y-intercept of 0. Okay? There is a linear relationship with a y-intercept equal to 0. Alright? That's how we know two things are directly proportional. And guys, this shows up all over the place. Okay? How much you're getting paid is a perfect example. Okay? You don't work, you don't get paid. You work an hour, you get 12 bucks. Work 2 hours, you get 24. 3, you get 36. Okay? So very simple, but it's directly proportional. Okay? Now, I said that we can also call this a variation. Okay? So there's two ways that we could say this. Alright, and you should be familiar with both of these. Okay, we could say that y is directly proportional to x, or we could use this terminology, y varies directly as x. Okay, it's slightly different terminology, but it means the same thing. Okay. There we go. So that's how we could say this. And in general, this is what we're talking about. Some kind of a linear relationship with a y-intercept equal to 0. Okay? Now, how do we tell if something is directly proportional? Okay? Now, I know that technically x can be 0, alright? But if you look, I'm going to copy this back down here. How can we tell if something, some relationship, something is a direct variation? the answer to this is for x not equal to 0, all right, because that'll mess this up. But for x not equal to 0, y over x will always equal the same thing. Think about that form we had, y equals kx. Well, if I divide both sides by x, this is what I'm going to get, okay? K will be by itself, and y will be over x, okay? Now, how is that useful? Well, let's look back at our data that we had, okay? The data we had was 0, 0. We're not going to use that point, but 1, 12, 2, 24, 3, 36, okay? So, let me add a third column to this. What would y over x be? Well, we're going to ignore that one, but 12 over 1 equals 12. 24 over 2 equals 12. 36 over 3 equals 12. All right? So, if you see that relationship, then you know this is directly proportional. And notice that value you're getting every time is what? But slope, if we think of it as a line, it's always k. And k is our, what's the term for that? Constant of proportionality. Okay? That's our constant of proportionality. Okay? That's our constant of proportionality. So that's how we can tell if something is proportional, directly proportional, and that's also how we can find that constant of proportionality. So if you're given a number of ordered pairs and you're asked, hey, what's the constant of proportionality? Or write an equation for this, you can easily find what that k is supposed to be. And then the equation will always just be y equals kx. All right? Does this make sense? Pretty clear? All right. Now, obviously we can do y over x for all of these. The key is that these all have to be the same. All right? If we got 12 for this and 18 for this and 24 for this, that's not directly proportional. Okay? So, this does have to be the same for all of these. Okay? All right. We'll take a look at some of those tomorrow. And tomorrow, remember, we do have that assembly at the beginning of the period. So as soon as that's done, we'll come back here.